right? So if you look into any database system structure, we have two components. One is going to be a storage manager component, right? One is storage manager component, and the other is going to be query processor component, right? So the storage manager is the component of a database system. So that provides interface between the low level data that is stored in the database and application programs and queries that are submitted to the system, right? So storage manager, it acts as an interface between the low level data that is stored in the database and the application programs and queries that are submitted to the system by means of an interface. So the storage manager is responsible for storing, retrieving, and updating data in a database, right? So the components of a storage manager includes authorization and integrity manager, right? So it tests for the satisfaction of the integrity constraints, and it checks the authority of the user to access the data, right? So authority and integrity manager, it checks for the authority of the user to access the data, right? So whether the user has read access, write access, or execute access on a particular data, right? So it checks for the authority of the users to access the data, and it also checks for the satisfaction of the integrity constraints, right? So for example, the integrity constraint, right, for a course table will be like marks should be greater than 40 for a student to qualify in an examination, right? So a student can at most register for 6 theory courses and two lab courses in a semester, right? So these are some integrity constraints in a course table. Maybe in a bank, the integrity constraints will be like the balance should be always greater than 1,000 rupees, right? To start an account, the age of an account holder should always be greater than 18 years, and so on, right? So authorization and integrity manager, it checks for the authority of the user to access the data, and it also checks for the satisfaction of the integrity constraints, right? Then we have this transaction manager. So you all know a transaction, definition of a transaction in the first class. So it's a collection of operations that performs a single logical function in a database application, right? So it's a collection of operations, but it performs a single logical function, right? So you pay your electricity bill, it's a transaction. So it has both debit operation as well as credit operation, but it performs a single logical function. It is going to debit your account, and it is going to credit into the electricity board account, right? So it's a collection of operations. A transaction is a collection of operations that performs a single logical function in a database application, right? So a transaction manager ensures that the database remains in a consistent state, right? So the database should be in a consistent state despite system failures, and concurrent transactions execute without conflicts, right? So here the transaction manager takes care of both atomicity problem and concurrent access anomaly problem, right? So it ensures that the system is going to be consistent irrespective of failures, right? So you all know that there may be different failures while you are going to execute a system, like hardware failure, software failure, power failure, disk failure, right, network failure, and so on. So you need to ensure that the system is going to be consistent despite failures, right? So a transaction occurs completely or not at all. So that's the property of atomicity, and it ensures that the concurrent transactions execute without any conflicts, right? To improve the throughput of a system, we should allow multiple users to pay the electricity bill at a particular time, right? And similarly, multiple people will be withdrawing from the EB account, right? So you need to ensure that the transactions, concurrent execution of the transactions proceed without any conflicts, and it is taken care by this transaction manager, right? So the next component in storage manager is that file manager. right? So it manages the allocation of space on a disk storage and the data structures that are used to represent the information stored on the disk, right? So file manager means it identifies the data structure that is used to store the data, represent the data, and it also deals with the allocation of space on a disk storage, right? So how to allocate space within blocks on a disk storage, it is taken care by file manager. So it deals with the type of data structure that is used to represent the data, and how you are going to allocate space on a disk storage. And finally, buffer manager, right? So the buffer manager component is responsible for fetching data from the disk storage into main memory and deciding what data to cache in the main memory, right? So whenever you execute a program or an instruction, it should be present in the main memory, right? To execute a particular instruction, the instruction has to be brought into the main memory, right? So buffer manager, it decides what data to be present in the main memory. It is also responsible for fetching the data from the secondary storage into the main memory, right? So these are the components that are present in storage manager, right? So storage manager, you have authorization and integrity manager. So it checks for the authority of the user relation. Then you have a transaction manager, right? So a transaction ensures that a transaction satisfies the atomicity property. It ensures that a transaction occurs completely or not at all. A transaction is consistent despite failures, and concurrent concurrent execution of transactions takes place without any conflicts, right? So this is the functionality of a transaction manager. So it ensures that the atomicity property is taken care, as well as this concurrent access anomaly problem is taken care, right? So it ensures that multiple transactions execute concurrently without any conflicts, and the transaction executes successfully, right? So it whether a transaction occurs completely or not at all, right? So the file manager component, it deals with the type of data structures that are used to represent the data, right? So what type of data structures are used to represent the data, and how to allocate how to allocate storage in the disk for the data. So the buffer manager decides what data has to be transferred from the secondary storage device onto the main memory, and what data has to be buffered in the what data has to be put in the buffer in the main memory, so that it can be referred over a period of time, right? So the storage manager, basically it acts as an interface between the low level data that is stored in the database and the application programs and queries submitted to the system, right? So next, the bottom tier, you have storage manager. Like you have a disk file. So disk file, basically it contains data files which is used to store the database itself, right? So the data file is used to store the database itself. You have data dictionary, which stores metadata, data about the data. It stores the structure of the database, in particular the schema of the database, right? So data dictionary is metadata. It is data about data. It stores information about the schema of the database. Structure of the database is stored in data dictionary. And indices for fast access to data items, right? So for quick and fast retrieval of data in a database, we go for indices. We also have statistical data, right? So statistical data, it contains some statistical functions like max, min, average, count, sum, and so on. which is used to apply some statistical operations on a particular relation, right? So these are the component available in disk storage, right? So data file is used to actually store the database. Indices for quick and fast retrieval of data, right? So your textbook indices, like indices are used for quick and fast retrieval of data. Data dictionary, it contains metadata, data about the data stored in the database. It contains the schema definition of the database, right? So you have some statistical data which contains some statistical functions that are being applied on a database, right? So the different statistical functions that can be applied in a relation are going to be sum of a particular attribute, sum, max, min, count, average, and so on, right? So this aggregate functions present in SQL, they can operate on a particular attribute and return some statistical information about the data that is present